Hello students, myself Anita Chaudhary. Today we discuss about the signed number and the unsigned number and how we calculate the complements of these numbers. So first of all, what is the unsigned number? So any number is representing using their magnitude, and the magnitude doesn't carry either its positive or negative, and so we by default we assume that the number is always positive number. So unsigned number are always treated as a positive number and they don't carry any of the sign bit. So the range of the unsigned binary numbers is 0 to 2 to the power n minus 1, where n is what? N is representing the bits. Okay, so if we assume that we have the n is equal to what? 2. So how many numbers it represents? It represents from 0 to what? 2 to the power 2, which is n minus 1. So from this, what is the range? 0 to 3. Okay, so we can represent three numbers using the bit 2 bits, which can be 0 0 0 1 1 0 and 1 1. So in the case of unsigned number, there is a no sign bit in front of the magnitude, and we treat the unsigned number as a positive number, whereas signed number, as the name suggests, sign bit is added into the number itself, and the numbers can be either positive number or negative number. So the number always carry one sign bit, and the remaining bit represent its magnitude. So the sign number make two possible representations of 0. Here is the interesting point. The sign number have two representations of the 0, positive 0 and negative 0. So the positive 0 is represented by 0 1, and the negative 0 is represented by 1 0. Whereas in the case of 2's complement, the representation of the 0 is 1 only. That's why the 2's complement is called unambiguous representations of the numbers. So we can see here the sign magnitude, like the as I have said that the positive representation of sign bit is 0, and the negative representation is represented by the 1. So let here the representation of plus positive 5 and negative 5. So positive 5, 5, how we represent 5 in a binary number system? 5 is represented by 1 0 1. Okay, now here how using how many bit we have to represent? Using the 5 bits. So we create a box of 5 digit, and from right to left we put the bits. So 1 0 1 is represented, remaining will be 0 0. As the number is positive, so the symbol of positive number is 0, so we put 0 over the most significant bit. Okay, same in a minus 5, we put 1 0 1 from right to left, 1 0 1, and the next remaining bit is represented using 0, and the sign of this number, because it is a negative number, so we put 1 for negative number. Okay, so that's how the representation of the sign number is done. Next, the positive 0 and negative 0. So the 0, the value of 0 in a binary system is 0 0 itself, and the number system is represented by the most significant bit. So for positive it is 0, and for negative it is 1. Likewise, plus 34, the value, the representation of 34 is 1 0 0 0 1 0, and the most significant bit is 0, that means it's a positive 34, and the negative 34 1 over the most significant bit position. So this this the first bit from the left side is called what? MSB, that is most significant bit, and the right hand side bit is represent the least significant bit position. Okay, remember this one. So the basic diagram of the number system in a binary number representation is uh, unsigned representation of the number and the signed representation of the number. So in case of unsigned representations of the number, all the numbers are treated as an positive numbers, and we don't never use the signed bit over the unsigned representations. Next, the signed representations of the number is having the three representation. One is the signed magnitude, which we have discussed, like positive 34 and negative 34, where the ambiguity is because of the two representations of the 0. Next, the ones complement of the number, there is also two representation of the 0 is there, so that's why this is also ambiguous. And the second complement form always carry only one representation of the 0, that's why this is called the unambiguous representation of the numbers. So how we calculate the first ones complement? So in a ones complement, what you have to do, you just transform the 0 bit into the 1 and the 1 bit into the 0. So what we have to change the 0 bit to the 1 and but 1 bit into the what? 0. So from likewise we get the ones complement, like plus 9 is representing using the 1001, remaining bit is 0, and because of the positive number, the most significant bit is 0. Now we convert this plus 9 into the ones complement, then the 1 is converted into the 0, and 0 is converted into what? 1. So all we have to change one by one, and we got the ones complement of the positive 9. Okay. Now how we got the ones complement using the circuit diagram. So for to got the ones complement, we apply the NOT gate. Simply we apply the NOT gate. So what the NOT gate you work? So NOT gate is basically convert the bit, either if the input is 0, then it convert it 1, and if the input is 1, it convert it into the 0. So there is a complement bit. Okay, so 1 is 1 to 0, 0 to 1. So that NOT gate is used for the to invert the bit. Now further there is an issue, like if we use the 4 bits for representation of the number. Now suppose we represent 7 using the 4 bit, then the number will be 0 1 1 1. Now if we apply here over the ones complement, then we got the number 1 0 0 0, which represents the 8. Now, if we represent the 12 using the 4-bit representation, then the number will be 1100. And if we convert it using in a ones complement format, then we got the 3, which is 0011. Okay. So this is how the number system work. Now, two's complement representation. So, two's complement, how we got the two's complement? We just convert, first we have to convert the number into the ones complement system, and after that, getting the ones complement, what we have to do? We have to add 1 into the ones complement. Okay. So now again, the two's complement number, the binary number system, the most significant bit is the, if that the bit is 0, then it represents the positive number. If the bit is 1, then it represents the minus sign. Okay, so uh, same, the positive 34 is converted into the ones complement 4. So how we do? We just convert 0 to 1 and 1 to 0. Now in minus 34, how we got the minus 34 in ones complement? So first represent the plus 60 in a binary number system, and then convert the 0 to 1 and 1 to 0, and that's how we got the minus 60 into the ones complement format. Now in a twos complement format, the first we got the ones complement and we add the 1 into the ones complement number and we got the twos complement. So here we look how the 60 plus 60 is represented into the ones complement sign magnitude number, ones complement number and twos complement number. So in a in a sign magnitude number, first we represent the 60 and we add for for positive system we add 0 only. Okay, in a ones complement number system, what we have to uh, uh, the value of the positive 60 is this one, and the in a twos complement system the number is this one. Okay, so they are got from the different criterias. Okay, so in a twos complement system, how we got the negative 34 from the positive 34. So what we have to do, either there is a two pattern. First we convert this 34 into the ones complement and then we add plus 1 to the for ones complement, or the next the shortcut is what, we just scan the number from the least significant bit to the most significant bit up to when 1 is detected. When one so what we have to do, we just write the numbers until 1 is detected. So after first 1 is detected, what we have to do, we just reverse all the bit which will be coming in the numbers. Okay, so 0 is same. Now first one is detected, we just what we have to do, we just write it here, and after that number the or we have to invert the number. So 0 is 1, 0 is 1, 1, 0, 1, 1. Now this is the twos complement number of plus 34, which is minus 34. Okay, so and the next, as I have told you, from the ones complement system we just got the ones complement of plus 34, and what we have to add the 1 into the ones complement and we got the twos complement. As you can see, the number will be same. Okay, so there are two different ways to got the twos complement. Now the range of the number systems. Okay, so the range of the ones complement is twos and twos complement because they both represent the plus and negative number both. So the range is from minus 2 to the power n minus 1, minus 1 to the 2 to the power n minus 1 to minus 1. Okay, whereas in the case of, because twos in a twos complement number, what 0 is represented by only one pattern. So the range of twos complement is from 2 to the minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay, so just because in a twos complement the representation of 0 is only 1, and that's why that is called the unambiguous. So here you can see that the representation of the 0 is 1 in a twos complement way, whereas in a signed number system the representation of 0 is different. Okay, positive 0 is represented using different number 0 0 0, and minus 0 is represented using the 1 0 0. whereas in ones complement plus 0 is representing using the 0 0 0 and the negative 0 is representing using the triple 1. Whereas if you can see over here, the numbers of in a 2's complement are not repeated, like 0 is represented only 0. There is no positive and negative for the 0. That's why the range of 2's complement is from minus 2 to the power n minus 1 minus 1. Okay. So also if you can check over here also the range from the numbers. Okay, so thank you. If you have any query, you can message me. Okay.